Alright, so I think I'm recording. Let's solve this exponential equation. We know it's an exponential equation because our variable is in an exponent. Alright. Now, one thing that's true about any equation is that the idea is that you want to isolate the variable. You want to get the x, in this case, as the variable and get it by itself. So on the left-hand side, I see two terms. The term of interest, the term that contains my variable, is this first term. I need to get it by itself. So the other term, I need to move it to the other side. So I need to add 32 to each side. And in general, I just think of it as that term changes sides on the equation. And if it changes sides, it changes sign. So I've got my 96 plus 32 over here. So this 4 raised to the x minus 4 is 128. Now, I need to write this with the same base. The idea is, so this 128 is 2 to the maybe to the 7th power. Let's play around. 2 raised to the 7th power. Okay, so I knew that 2 to the 5th was 32, so I knew it had to be a little bit bigger than 5. Alright, so the 4, I can easily see that 2 squared is 4. And this 4 is being raised to the x minus 4 power. And this 128, I can rewrite the number 128 as 2 to the 7th power. And now, when you have a power raised to a power, you multiply these exponents together. And this 2, I have to distribute that through that binomial. So I get 2x minus 8. And that's equal to 2 to the 7th. So now we use the property, the fact that exponential functions are what they call one-to-one functions. It passes a, not only does the graph will pass a vertical line test so that you can call that relation a function, and then the function achieves a promotion, a new title. Since it passes a horizontal line test, this function achieves the title one-to-one function. Alright, so since it's a one-to-one function, that allows us to recognize that if the numbers are the same and the base is the same, then the exponents have to be the same. So this is a two-step equation. In 2 steps, you can get x by itself. On the left-hand side, there's 2 terms. The term of interest is that first term. So we need to get the terms that have a variable by themselves and grouped together on, say, on the left-hand side, and I'll have all the constants that don't have variables on the right-hand side. So this minus 8, if it changes sides, it changes sign, and I add 8 to each side. I have 7 plus 8. So 2x is equal to 15, and on the left-hand side, I have 2 factors. The factor x is the variable of interest. So to undo this multiplication of 2, the inverse of multiplication is division, is we divide both sides of this equation by 2, and 2 divided by 2 is 1, so we have just 1x, and 15 divided by 2, I'm just going to leave it as 15 over 2. If you want to write 7.5, you can. Now, the original equation was an exponential equation, which exponential functions have a domain of all real numbers, so I don't expect to have any extraneous solutions. If I haven't made a mistake in getting this x by itself, then this is the answer. You know, there are times when it's just that when we get to this point, it's a list of possible answers, and to get to the final list of true solutions, that you have to check into the original equation and make sure that you don't have an extraneous solution. But that's when the domain is different than all real numbers. For this equation, x could be anything, and we found it to be 15 over 2. Hope that helps, and I'll talk to you later.